So here we have a rectangle, and all the properties of a parallelogram still apply. And then we also have these extra two special properties that make it a rectangle. And so we start with the fact that we have 90 degrees at each corner. And we also know that the diagonals are going to bisect each other and that they are congruent to each other, which is telling me that all these parts are going to be congruent to each other, right? And so we're trying to find all the angle measurements that we can here. So we start off with the very basic one, which is these two are vertical angles, which is telling me that that's also 64 degrees. And so if that is 64, notice how these two angles here are supplementary or a linear pair, which means that they're supposed to add up to 180 degrees. So if one of them is 64, we simply subtract from 180 and we get the measurement of 116. And so if that's 116, that means this is also 116 because they are vertical angles. And so now we're not stuck, but we have to be a little bit more clever, right? So I'm going to use my little highlighter here, and I'm going to highlight this triangle, and tell me what you notice. So notice how two of the sides have the same markings, which means that this is a isosceles triangle. And so for an isosceles triangle, remember, isosceles triangles have two sides that are the same, which means that it has two angles that are the same. And so that's telling me that these two angles here are going to be congruent to each other, right? So if they're congruent to each other, that means that whatever 180 minus 64 is, which is 116, that means 116 degrees is left between these two angles, and it has to be equally spread out, right? So we take our 116 and divide it by 2, and that tells us that in each angle we have exactly 58 degrees. So that's 58 and 58. So we can do one of two things. One, we can recognize that this, we'll say 1 and 2, these two triangles are congruent because they both have the same side, the same angle, and the same side, right? So remember how we proved triangles are congruent? Side, angle, side. So side, angle, side, same angle, same side. We can also recognize that because these two lines are parallel, you can think of kind of this line here being my transversal, and so this angle there and that angle there are going to be alternate interior angles. And so since it's alternate interior angles from parallel lines, then they are going to be congruent. And for the same reason, this angle here is going to be exactly the same angles there because they are alternate interior angles, or once again, you can recognize that they're congruent. And so that takes us to the next angle, which is this angle here. How do we find that angle? Well, remember, at each corner we have 90 degrees, right? And so if that corner is supposed to be 90 degrees and I just found one part of that angle to be 58 degrees, we simply subtract and we get 32 degrees, and that's all the way around. So 32, 32, 32, and 32. Okay, so let's move on. So we have another problem, and in similar fashion, we're trying to figure out everything that we can, right? And so to start off with, opposite sides are going to be congruent. So that's 10, that's 10. This bottom part is 24 and 24. And so we're going to go ahead and find the measurement of this diagonal here. Okay, and the way we do that is a little bit trickier to see, but we kind of take it a little step back and see that we have a right triangle there. And that's important because on a right triangle, we have a right angle. And so I'm going to redraw that triangle on the side here so we can see it a little bit better. But really, this is the right triangle that we're looking at, right? With this side being 24, this side being 10. And so if you notice, for a right triangle, we can use Pythagorean theorem, right? So we'll say this is A and this is my B. And remember, the only one that matters is what you label C. C is always going to be the hypotenuse, or the longest side of the triangle. And so here, we're going to use Pythagorean theorem to find that diagonal, or this C, right? So here we have, and remember, A squared plus B squared equals C squared. That is Pythagorean theorem. And so since we're looking for C, we're going to take the square root of whatever A squared plus B squared is. And so here, all we simply do is substitute in what we know. So A is 24, and we're going to square that. B is 10, and we're going to square that. So we have C is equal to the square root of, so 24 times 24 is 576. 10 squared is 100. Add them together, and we are looking for the square root of 676. So the square root of 676 is going to be 26. And so this diagonal, now we have to be a little bit careful here, because yes, C is equal to that, but it's actually QS, which is telling me that each segment, if you remember, because the diagonals bisect each other and they're all congruent, each segment is going to be half of 26. So in this case, they're all going to be 13, or 13, 13, and 13, right? And so let's go back to, how do we find this other angle? So remember, there's supposed to be a 90-degree angle here, right? And so if one part of that 90 degree is already 27, we simply subtract 27 from 90, and we get to be 63. And by the same argument of the last problem, if that's 63, this is 63. And the reason for that is because we have a we have an isosceles triangle here, right? So here is my isosceles triangle. I know it's isosceles because it has two congruent sides, which means it would also have two congruent angles. And by similar fashion, this is going to be 63 and 63. You can view it one of both ways. So you can see that there's two congruent triangles, or they're alternate interior angles. And so this means that this is also 27, 27, and 27.